I think, yeah, there you go. Good afternoon. I sound echoey, is that just me? Or is it sound okay for everyone? Yeah, good. Well, welcome. If you haven't seen me this morning, my name is Richard. And I do work for Oracle. I'm a VMware solution specialist there, helping VMware customers towards the Oracle Cloud, traditionally using VMware in our cloud. But today's session, don't worry if you don't want to use Oracle Cloud, is about HCX, about migrations. And it's a VMware technology, and it really doesn't matter for most things if you use VMCs, VMware's own solution on AWS or Google or whoever, it's all the same. So it's a generic session. But what is this topic all based on is that this is the most common request I get from customers. It is starting to become very popular that customers want to close down their own data center. They do realize that running an own data center is expensive, or even if it's a leased data center, it's expensive if it's just for you. And more customers are fully deciding before the end of the year or before the end of my lease contract, whatever, I want to shut everything down. And first question is then, are you running everything on VMware? Typically they say yes, but of course they don't run everything on VMware. They have hardware appliances, they have other platforms that they forgot to think about, so those are challenging things. But from a VMware's perspective, with having VMware in the cloud and having VMware on-premise, one thing that we can do is we can move things and not migrate things. That's the real big difference. It's not a migration, it's a move. I always explain it to salespeople, saying, hey, if you put a rabbit in a box, and the box has no windows, if you pick up the box and just put it somewhere else, the rabbit didn't know it moved. From the internal of the box perspective, everything still looks the same. That's a move. If you take the rabbit out of the box and you put it into a similar box, hopefully if the box is as similar as possible, the rabbit doesn't know, but you're not sure. That's a migration, right? With VMware to VMware, it's a move. The virtual machine is being moved, MAC address can stay the same, virtual machine hardware can stay the same, IP addresses can stay the same, all that kind of stuff. And I'm always still shocked how many people care about this. Most companies that I speak to, if an IP address changes, the entire system falls down flat for some reason. I never understand why. DNS has been in existence for a long time, but for some reason people hardcode IP addresses and everything. So that is the challenge that we're trying to solve. How can people, for instance, close down a data center or a subpart, move it to the cloud, not migrate it because they can't have anything changed, because they're running Windows 2003 or other old shit. An application installed by someone 15 years ago that left the company 10 years ago and no one knows how to reinstall it or doesn't want to touch it. If it runs today on VMware, I don't care what it is. If it's an old MS-DOS application, if it today runs on VMware, you can run it in VMware in the cloud. Because the VM, everything stays, and VMware is incredibly good backwards compatible with virtual machine hardware. So you can really take very, very old virtual machines and run them. Now, as I said, this is something that you can do across all clouds. There are differences between the different flavors of VMware in the clouds. It's all standard vSphere, Enterprise Plus, vSAN, NSX, and all that kind of stuff. The high-level big difference is that on VMC, AVS, and Google, you get a managed VMware environment. So they actually are running VMware for you, and you just get a user access account to their vCenter so that you can do things, but it will give you full HCX access. In the Oracle Cloud, you get a VMware environment that is just yours. So we're not managing it. You have full root level ESXi access, full admin access to vCenter, full access to NSX, everything. And we don't, so you really have to manage it yourself. But therefore also we don't impose any technical limitations. So but in the end, the stack itself is everywhere the same. It is standard, well, the versions, we offer version 7 and 8. I think VMC now is offering 8 as well. I'm not sure where Azure and Google are on version-wise. But that's the stack. Now, all of these things come with HCX. And HCX is a component that sits in the cloud and a component that you actually have to deploy in your own data center. I'll come to that. But the main thing what HCX is designed for to do, it can do a few other things, but the main thing what it is designed for to do is to help you do this, and they call it migrations. Well, it's not a migration, it's a move, but it helps you to do migrations. And it has 3 types of there's a few others for physical to virtual as well and that kind of stuff, but In most cases, when you go from VMware to VMware, there are three types of migrations. One is a bulk migration. And a bulk migration just means that, say, okay, I have 10 virtual machines here. I want to put them in the VMware environment in the cloud. What it will do is it will replicate the storage of those virtual machines while the virtual machines, of course, are still running. And when that replication is complete, you can tell it to a certain maintenance window, or whenever the replication has been completed and the delta is small enough, what it will do is it just power off those 10 virtual machines here, power on the 10 virtual machines there, and then just in the reboot cycle, the virtual machine has moved from on-premise and launches up into the cloud. This is not vMotion based, so this can actually happen, for instance, from Intel to AMD architecture. You don't, if it's even from Intel to Intel, but it's a different generation, you don't have to worry about those kind of things because it is a reboot cycle that is required. The second methodology is using vMotion. And with HCX, you can vMotion a virtual machine across. Now, there's a few things about this. There's a dependency that, of course, if you vMotion, the network cannot change. So a component of HCX is, and that's something we'll in depth talk about today, is that HCX allows you to extend the network segments. So you can have an on-premise network segment, and it doesn't have to be NSX. That can be NSX or a distributed switch, normal port groups. And it can take those network segments and stretch that into the cloud so that the virtual machine can be moved while staying on the same network, and therefore you can vMotion. Now, the downside with vMotion is, again, if I have those 10 virtual machines and I want to vMotion them all the way to the cloud, vMotion is something that does not happen in parallel. vMotion is something that happens in serial. Unlike the bulk migration, with bulk migration, it will replicate 10 VMs, and at the maintenance window, it will power all 10 VMs off, power all 10 VMs on. All 10 VMs move pretty much at the same time. With vMotion, it would mean that I have the 10 VMs, it will take VM1, does storage replication. When storage replication is done, does memory replication, a few cycles, and then switch over. Then it goes to the next VM. Storage replication, memory replication, next VM. So suddenly, moving those 10 VMs over using the vMotion profile might mean that, depending on how large your VMs are, that 2 live there, 8 live here for a few days, and it will actually take some time. And of course, while they stay on the same network, the latency definitely won't be the same if one lives there and one lives there. So that's a consideration you have to be thinking about when you use vMotion. So therefore, there is also a third alternative, which is called a very complex name, assisted vMotion, or I think it's even a longer official name. But what does that do is a combination of the two technologies. It will take those 10 virtual machines, first replicate the storage of those 10 virtual machines across on the other side. When all the storage is replicated, then it will only do the actual vMotion of the memory of the 10 virtual machines. So it will still go in series, but the storage part has already been completed. So it will go significantly faster than traditional vMotion. So you have a shorter window when VMs lives on one side and on the other side. So those are in general the three mechanisms of how you can actually take HCX and move things across. Now, how do you set this up? When you actually have a VMware environment in the cloud, typically it's already pre-deployed with an HCX Manager appliance. And in there you can set up something called side pairing. You make sure that there's connectivity between your on-premise VMware environment and this. So the way you do that is you download an appliance, and that appliance, that HCX, what they call the HCX connector, is something you deploy on your own VMware environment. Now, this is something I always make very clear to my customers, because not every customer, especially in POCs and POCs and that kind of stuff, are willing to do something to touch their existing on-premise VMware environment. But if you want to do anything with HCX, you have to be willing to deploy an HCX appliance on your own existing VMware environment. And that appliance, needs to be able to talk to the appliance that sits in the cloud, and it needs to be able to talk to your local vCenter and ESXi servers, because it will take care of all the stuff. Now, that's just the manager part. When you have that manager, you can configure the side pair, and you can configure something called a service mesh. And in the service mesh, you're going to say what HCX is going to be capable of doing. So can it do migrations? Well, of course, you'll do that. Do you want to have network extensions? Do you want to have WAN optimization? And all those things will require additional virtual appliances. So in the end, actually, when you deploy HCX, you have an HCX manager on both sides. The local side is called the HCX connector, but it is an HCX manager. And then you have an appliance for each individual service. So you have an appliance, the IX appliance, the inter-exchange appliance, which takes care of the vMotion traffic and the storage replication traffic. You have an any appliance for the network extension. You have a WAN optimization appliance, if you have this, depending on what you've configured in your service mesh. So you see all these virtual machines pop up in your environment, and the even more confusing thing, I forgot to put a screenshot about that in there, is what HCX does locally, and well, it also does it in the cloud, it creates a dummy ESXi server. And people are like, hey, where does this ESXi server pop up? I didn't install a physical server or something like that, but that's the dummy server that HCX uses to send all traffic through. So it's just a strange artifact that's there, so don't be shocked about it. But if you set all of this up, you can then actually start thinking about configuration. But the first thing then you first have to do, of course, is get the connectivity going. And for a lot of customers, that often is already a problem. This is an example from the Oracle Cloud, but I'm pretty sure networking-wise, this is very similar to most other clouds. So in our cloud, you create something called a VCN, a virtual cloud network, VCF, or I think it's in Azure, or VPC in Azure, so for your private cloud. So you have a cloud bubble, and in that bubble, we deploy the ESXi servers. That's the normal standard layer 3 subnet. ESXi, the VM kernels live there. And then internally in our cloud, we also create some VLANs, and that's where we put the things like the vMotion network and the storage replication network. But this is also where we put our manager, so the vCenter server and that kind of stuff, and the HCX manager. Now, of course, on top of this, I can create NSX, so I can have normal local NSX segments that only live in the cloud. But for HCX, the whole goal is to take those on-premise networks and get those on-premise networks extended to my NSX layer. So that's what HCX can do, is it can, by installing these service meshes, by installing these appliances, I can now start making these extensions. And that kind of stuff. See it a little bit like a VPN tunnel. HCX tunnels all that traffic over and allows you then to create all these connectivities. Now, if you have all this configured, the fun can start. You can start doing these movements of virtual machines. But there's a lot of things you have to think and consider about. So let's take this example. I have my on-premise data center. I have my in the cloud VMware environment. HCX is all configured and that kind of stuff. And I want to start moving some stuff over. I have 3 network segments, a blue, an orange, and a green network segment. And I want to start moving some stuff over. The first thing, of course, I have to do is say, let me create a network extension. I'll extend this application network, the blue network, over. So I have the blue network now suddenly live also in the cloud. Well, that's easy to configure, set with the service meshes. But what if I now actually, and right now all my application servers still live on the left side. So the ping times to my application servers and database servers, you see in the top left, is whatever I have locally less than 1 millisecond latency. If I now actually move a virtual machine over, so I take an application server, keep it on the blue network, but I suddenly run it here. I don't care if it's through bulk migration, vMotion, replicate system vMotion, that kind of stuff. It still sits on the same network, but of course the distance is significantly bigger between them. And I put in here right now 80 milliseconds. That's my time between my home and my Frankfurt data center. But that would of course be whatever you have. And if I take a look at most of my customers, if they're using a region that sits in the same country, they typically have around 10 milliseconds, sometimes less, sometimes more, but I think that's the average latency you would typically have between, if you have something relatively close between your on-premise environment and the cloud. So suddenly you have that distance between those machines. And well, it depends of course on the workload, if it can deal with that or not. Now imagine that if I have moved this over and I want that application server that sits now in the cloud to talk something that also sits in the cloud, but natively. So imagine in our cloud, for instance, I do work for Oracle, I have an Oracle database server natively running. Don't want to run it on VMware from a licensing perspective. I'll run it nicely natively in the Oracle cloud. Now imagine how this traffic would go. That application server sits on the blue network segment, which is an on-premise network segment. So by default, that traffic of that application server will flow to the on-premise environment. From there, hopefully have a VPN or a fast connect, direct connect, express route, whatever connected into your cloud, and it will find its route to its native service. So suddenly, this machine that has moved into the cloud and wants to talk to a resource in the cloud has a network latency that is not even just one time the latency between me and the cloud, but 2 times, because it goes on-premise and back again to that resource. So you really get shit poor performance now suddenly for this moved virtual machine. So that's a challenge. So VMware has invented to solve this problem an additional functionality within HCX. You require HCX Enterprise for that, but I think most clouds nowadays provide this by default. And it's a functionality called Mobility Optimized Networking. I'm not sure what that name really stands for, but what that does is with Mobility Optimized Networking, I can actually control where traffic exits out for each individual virtual machine without changing anything inside the virtual machine. So that virtual machine that sits on the blue network segment, oh dear, my audio. The virtual machine that sits on the blue network segment has a default gateway set to whatever the default gateway of that blue segment is that lives on premise. That doesn't change. But within HCX, with Mobility Optimized Networking, I can define what network segments I have that are classified as on-premise. So I can say anything 192.168 sits on-premise. And therefore, by default, that traffic will just flow as if it is part of the network to on-premise and that kind of stuff. But anything else, if I, for that virtual machine, turn on Mobility Optimized Networking, whenever traffic is actually sent to its default gateway address, HCX interferes and takes that traffic and actually exits it out on the NSX side in the cloud. So without any IP changes for the virtual machine itself. So the machine only has one default gateway, which points there, but still traffic gets stolen away from it when it wants to talk to the cloud, and then can do. So if I configure this, if I configure what my on-premise segments are, and if I turn on Mobility Optimized Networking for this virtual machine, suddenly now when this virtual machine is sitting in the cloud and is talking to a native service, by magic, its traffic will flow on the right side out towards the NSX layer directly into the cloud, and suddenly I get around 1.1 milliseconds of latency. And I consider that high. That's not because our cloud is shitty, but NSX does introduce overhead. So normally in our cloud you have 0.2 milliseconds, so NSX adds about 1 millisecond overhead using MOM, going to tier 1, going to tier 0, going to local. But it's still better than going back, going front. So suddenly I have this now configured. And so even though it sits on my on-premise blue network, it can optimized talk to anything that sits natively in my cloud without doing that tromboning of its network traffic. Without any IP change, without the virtual machine itself being aware of it in any form or shape. Oh, right, all problems solved. I can move everything, can talk to load. But of course, life isn't that simple. That machine can talk to it, but that's of course one-way traffic. Because if my machine that I have in the cloud wants to talk to that IP address of that application server, well, keep in mind that was sitting on the blue network segment. The blue network segment is an on-premise network segment. In my cloud, I would have route rules configured that on-premise segments need to be sent to my Fast Connect, Express Route, Direct Connect, whatever you've called, or your VPN tunnel, and we'll send it to on-premise. So if it wants to talk to that machine, it will actually send traffic to on-premise blue network. There it will try to reach the VM, and actually it won't have communication with it because the machine has moved with MOM enabled, and that traffic won't flow over the line anymore. So suddenly I've broken connectivity with that machine. So if I want to do this, there are 2 scenarios that I can do. First of all, when I have this configured, I'm not sure if it's on this slide, I think so. By default, NSX will configure a net rule for this virtual machine. So that's why traffic out will work, because it will just net route, the source net routing on it. It will say whenever traffic flows out, it will take over it will net it with the IP address of the NSX layer. And the IP address of the tier 0 is known in the cloud, so that's where traffic will be sent back to, so it will get back to the VM. But as I said, if the session needs to be initiated from the native cloud towards that MOM-enabled virtual machine, what you need to do is you need to override the routing rules, literally a /32, is specific just for that IP address, saying, hey, I know this is the blue network segment, but for this IP address in this blue network segment, don't send that traffic to the on-premise VPN tunnel or whatever you have. No, send that to the tier 0 IP address of your NSX layer so you can go to that virtual machine. And if I configure this, it's on work, Highly recommend doing that through automation using Terraform and those kinds of things. I can now move a virtual machine, keep it on the on-premise network, but it can completely still talk to anything on-premise, but it can now also talk to anything that sits in the cloud directly, two-way communication. Doesn't matter who initiates all that kind of stuff. So you really can get the best of both worlds with that virtual machine. Now, sometimes when we do this, customers are happy. But some of our customers, for instance, in our cloud at least, they spend a lot of money on running an Oracle database on something called an Exadata. It's a really expensive box in our cloud that you can run a database on. Very high performant. And they say, well, great, but that 1.1 millisecond latency, whatever I have, that's not good enough. On-premise, I had 0.2 millisecond latency or something like that. And I hear suddenly I moved to the cloud and you told me cloud was better than on-premise. Suddenly I have crappier stuff. So then we have to go get creative. The only way to do that, to get lower latency, is by bypassing NSX. NSX is very fast between VMs, but NSX is relatively slow if it has to exit outside of the NSX layer through tier 1 and tier 0. So the way and how we can do that is we can take that virtual machine that I have there and cheat a little bit, because I wasn't allowed to change its IP address, but no one told me really to say, well, why can I not just take that virtual machine and just add an extra VNIC to an extra network card to it, a virtual network card to it, and take that network card and directly inject it into a VLAN that sits in our cloud. Now, this is something I don't think you can do with other clouds, but you can do that with the Oracle Cloud. So I can take that virtual machine, don't change its IP address, but I can give it an additional IP address that sits in the native segment in the Oracle Cloud, directly VLAN attached, no NSX, and therefore can talk to that database or whatever service it is. And suddenly, of course, the application needs to talk to a new IP address, but the IP address of the VM itself didn't change, but the application does need to talk to a new IP address of the database. Doesn't have to actually change the IP, but I have to change the routing rule inside that virtual machine. That IP address has to go out of the second NIC. If I do that, I suddenly get 0.2 millisecond latency between a VM that's on my on-premise network segment talking to a native service in the cloud. So something very nice that you can configure all the way. But of course, in real migration scenarios, this is still way too simple. Customers, of course, are moving many things at the same time. So imagine I didn't just extend the blue network, I also extended the orange network segment. And I decided that application 1 belongs to database 1, and I make a migration plan that I move both at the same time to the cloud instead of just one, so that I don't have this distance problem. When I do this, and I would, for instance, turn mom on one VM, and I don't do it on the other one, I have a big problem. Because again, then, by default, its traffic will flow on-premise. That was where the orange network supposedly lived, and then from there it will flow back to the orange networking. So when you start doing this, you really have to make sure that mom is enabled on all of your segments, on all of your virtual machines, all things are moved. Because if you do enable mom on both VMs, automatically in NSX/32 routing rules are assigned to them, that traffic is automatically captured away, and traffic is routed then directly on the NSX layer between those virtual machines, and you get 0.2, 0.3 millisecond latencies between them. But this really allows you to take workloads and design in what phases you want to move stuff over and do that. Now, this is still always a problem because I make it look simple. I have application server 1 with database server 1, and they are dependent on each other. I'll put them into one migration project, move them in a weekend over, set 2. Of course, in real life, nothing has a one-to-one relationship. Things are spaghetti connected to each other, and a lot of companies struggle understanding, well, which part can I move, and are there still dependencies left over? And if you miss something and it had a relatively low latency requirement, suddenly you get very poor performance. And I have seen many customers when they've done a migration cycle that they move back because they broke something. Well, they didn't break anything, just introduced latency, and the application completely poorly performed after that. So a lot of companies struggle finding the dependencies on that because you really want to design your migration waves that, yeah, whatever sits in the same dependency to move over. So that's always a big challenge for customers to figure out. So what are the real world issues with this? This is all theoretically and all that kind of stuff, but if you start doing this in the real world, you hit even more problems typically. One of the biggest ones I find is this whole concept of running hybrid. When you're in the middle of, so most customers, I'm working right now on 2 big projects, and one has in total 9 months to migrate everything, and the other one had a little bit less than 12 months. And during that whole phase, some stuff live here, some stuff live there. And customers always underestimate what that will do to applications. If you suddenly have 10 millisecond latency versus 0.2 millisecond latencies that you have on-premise, a lot of applications suddenly can break. And if you really didn't understand the performance and you misjudge what depends on each other and that kind of stuff, I've seen a lot of customers having to roll back stuff because they didn't know what the dependencies were and that kind of stuff. So this is a big thing. And ideally, I'm a big fan of not looking at what things are connected to each other, but just move entire network segments over, stop layer 2 network breaking, just route traffic, and go as fast as you can. Now, of course, not all companies allow that. They can only do weekend migrations or whatever stuff. But I am not in favor on having layer 2 network extensions for a long time. And I even think VMware officially in their documentation will say that this whole layer 2 extension concept is something designed for during the migration. I have customers that want to plan on doing this forever. They want to have forever layer 2 extensions. And while technically it works, and VMware has massively improved some of the components of it, until like even I think 8 months ago, the 2 appliances that were responsible for the extension were not configurable as HA, as in the form of that you can run them redundantly. So if something happened to those appliances, you literally break the network in your environment and you have a big problem. Nowadays, you can run the appliances in dual mode, so you have 2 appliances running on both sides. You can do rolling upgrades, so if the appliance needs to be updated, and HCX requires a lot of updates, almost at least once a month there's an HCX update. It does it rollingly, so it will spin up a new appliance with the new version, and literally in less than a second it cuts over between the old and the new one. So you can do full rolling up. So it is significantly improved, but I would highly recommend, if you can go fast, don't do a long-term hybrid concept. Then besides that, there are some minimums. You do need to have certain minimum requirements, bandwidth-wise, latency-wise, packet drop-wise, for the different migration technologies. I think in general, you need to always have at least 50 megabit of bandwidth. And that sounds normal, and I hope most of you have more than 50 megabit internet connectivity. But I have customers that are in Kenya and want to connect to a data center in Frankfurt, and they don't have anywhere near these kind of bandwidths. And they still think that they can move everything to the cloud. And even if it technically worked like this, if you have 1 terabyte and you want to move 1 terabyte over a 20 meg link, well, do the math. It's just going to take freaking forever. So it just doesn't make sense. So, but in general, it's at 50 megabit, you need to have at least, and you need to have less than 150 milliseconds of latency. Now that's the minimum requirements. Typically, the most thing I struggle with my customers is the maximum, the limitations of HCX. You have all these appliances, and these appliances all have limitations. The IX appliance is an appliance that takes care of the vMotion traffic and the storage replication traffic. That appliance, you can only have 1 per service mesh. So you can't have multiple, so you can only have 1 appliance taking care of the replications between one vCenter and another. You can't have multiple service meshes between 2 vCenters. So you only have 1 service mesh, 1 appliance that takes care of that. And that appliance is limited in total to about 1.52 gigabit a second of traffic. So even though I have a 10 gig pipe between my on-premise environment and the cloud, great, if I do data transfers and all that kind of stuff, I'm going to hit that limit. And that limit is the max of the appliance itself. Underneath it, the type of sessions it does, for instance, for replication and that kind of stuff, those limits are even less. So if you want to convert, if you want to like copy over 1 terabyte, even though I have a 10 gig link or something like that, it will not use that capacity anywhere near it. And it will therefore go significantly slower than what you would expect it, and therefore you might not make your maintenance windows and that kind of stuff. So very important that you know what these limits are. I'll later give you a link. VMware actually has an extremely good document where they first of all describe all these limits, but also have sample calculations basing on what your limits is, how much data you want to send, what they think, what the duration actually would be, and that kind of stuff. So it is relatively well documented. The layer 2 network extensions, the appliances that create the network extensions, they are stackable, or they can run in parallel. So if you, for instance, want to extend 20 network segments, first of all, then you would have to have multiple, because every single appliance can only extend up to 10 network segments. Now, I don't even think you should ever try to do that, but it can do a max of 10 segments. So if you want to have more traffic or more bandwidth, for one segment you can't increase it, but you can say, I will spin up more of these appliances on both sides to say, okay, these 2 network segments are going to this appliance, these 4 network segments will go over these appliances. So you can actually have that fully in serial. But still, per appliance, its bandwidth is up to 4 to 6 gigabit of bandwidth. Again, if you have a 10 gig link to the cloud, and you thought that you're having a network segment extended with your 10 gig, that doesn't really apply to the real world of what kind of bandwidth you will get over that link. Per network flow itself, so if I do a file copy, just a single TCP session, is less than 1 gigabit, independently of what bandwidth I have, independently of how my appliance is balanced. So those are limitations that might sound like high, but I have customers that want to move, like I have a customer last week tried to move 2 10 terabyte file servers, and they had to do it over the weekend because that was their maintenance window. And 2 times 10 terabytes, even if you have good connectivity, still takes some time because there's lots of overhead and all kinds of things happening and that kind of stuff. So they managed to do it, but they shouldn't have done 3 10 terabyte machines. I don't think they would have accomplished that. But as I said, VMware has a really good document. It's a very simple link on there. Where they give all kinds of examples. They have examples for vMotion traffic, they have examples for replicated assisted vMotion, the bulk migration, with all the different scenarios in how much bandwidth you actually have, how much disk space you want to move, and that kind of stuff for with vMotion. And with vMotion, what's really important is how much memory changes are going on. vMotion is a continuous process of replicating the memory, and it has to get small enough so that it can actually vMotion. If you're trying to like vMotion a database that does massive amount of transactions, the storage replication is not typically the problem. It's the memory replication that changes so heavily that vMotion has a hard time keeping up with replicating the memory states. So with those servers, you probably don't want to do vMotion. You probably want to go down, plan a maintenance window, do a bulk migration, and power it off and power it back on. It will be significantly faster than trying to do that through vMotion. So definitely a very good document. If you ever want to go do this at large, I highly recommend you read this documentation. It's like 20 pages, very detailed, all the limitations, how to set it up, and that kind of stuff. So that's about it. That's what I want to share. Is it possible to vMotion stuff into the cloud? It absolutely is. It's mind-blowing when you see it for the first time. By the way, I hope I've made it clear, it can always go 2 ways. So going to the cloud is not a one-way street. vMotion works as simple, or HCX works as simple from A to B or from B to A. So I have done with many, many customers, and they move things over, had performance problems, we first moved stuff back again, figured out what the real dependencies were, make a new plan, and then move everything over and that kind of stuff. So you can absolutely move up and down, use it even as a temporary solution. So we have customers that since the war in Ukraine that suddenly thought about, hey, maybe my own data center is probably not the safest place to run my stuff. So they actually all evacuated or built up evacuation environments in Frankfurt, moved things over there, and whenever they felt it was safe again, they are moving things back again. So you don't have to do this for permanently. If you, for whatever reason, you only temporarily need to move your stuff over into the cloud, HCX can really be used for those kinds of things as well. One final thing about HCX is that HCX can do other things. It can also do disaster recovery. It's not as good as SRM, even nowhere near in my opinion. But if you want to have a basic disaster recovery model, with HCX, you can say, okay, I want to protect these 20 virtual machines, and HCX will permanently do replication of those 20 virtual machines. And when it fails, you can go to the HCX manager in the cloud, say, hey, go recover these virtual machines and it will power on those virtual machines. It doesn't have the extensive runbooks and all that kind of stuff that SRM has, and it can't do many of the other complexities that SRM can do, but if you want to have a basic model for failing over virtual machines, you can actually use HCX for that as well. And as I said, HCX, all its functionality is all the same across all clouds. It doesn't matter which cloud you use, it is just VMware HCX to VMware HCX. All the underlying technology after you set it up is completely hidden from it. It's just from VMware to VMware. It doesn't see the cloud that sits underneath it whatsoever. That's it for me. A little bit short, I think. Didn't plan a 45-minute session, but any questions? Yes?
Is HCX supported in the air-gapped environment if you want to migrate one site to another?
In a what? In what kind of a?
Air-gapped.
Air-gapped environment. You need to have internet connectivity. You need to have connected to the environment, if that's what you mean.
If you don't have internet.
Oh no! Oh, good question. I think I had a slide on it. Did I not? Oh yeah, I did. I just didn't talk about it. So good question. HCX has a requirement, which nowadays I am being more expressive to my customers about it. HCX requires internet access on-premise. Not a choice, and it permanently needs it, because anything that VMware does in the cloud, and HCX on-premise is part of the cloud solution, is subscription-based licensing, and if it is subscription-based licensing, it continuously needs to check with VMware servers if it is still properly licensed or not. I have multiple customers that refuse to give internet connectivity to anything. Well, then you can't use HCX. That's simple. You need internet to provision a VMware environment in the cloud because it needs to license the keys once. But for HCX, it needs to have permanently connectivity. It says there license activation, but it needs to be permanent to check licenses. Because it is a subscription base, if you only need it for 1 month, because you only need for 1 month migrations, after that you can terminate your HCX subscription, not pay for it anymore. Therefore it does check. So it does need it. But the HCX connector that sits on-premise does support all methods of internet connectivity. So you can have a proxy configuration, you can send it through your own firewall. So you can if you want, but it does need to have, VMware will know that you're doing migrations. You can't do migrations with HCX secretly without VMware knowing. Gabriel.
Since you're always talking about moving to the cloud, and you're talking about now the internet connectivity, can I use this to in-source a new customer of mine into my on-premise?
If it's from a non-VMware cloud to non-VMware cloud, I don't have experience with that, but then the product is just licensed, not subscription-based, then I think it does not require the connectivity, maybe only for activation, but not for permanently ongoing thing because it's perpetual licensed. So from on-premise from a normal perpetual licensed VMware platform with HCX to a normal perpetual license thing, I don't think you have this problem, but I personally don't have experience with that. I only do cloud. Yeah, good one. I forgot to mention. So that's, it is in this same picture here. It doesn't. A lot of people always think, oh, but in the cloud I have NSX. Do I need to have NSX locally? No, you don't. It doesn't matter. A VM just connects to a network label. Doesn't even know what technology is underneath it. But it does need to be a distributed switch or NSX. So if you are really old school, hope not, and you have standard switches, you first have to upgrade to a distributed switch. Else it can't do. And that's so you can still always use as HCX, but if you want to do the network extensions, for network extensions, it needs to be a distributed switch or NSX to have the extension be created. Also things like I don't know how many people do it, if you run federation, you can't do it. If you use, I think someone earlier talked about it, but if you do layer 2, if you already do like layer 2 VPN, if you already have any other form of something that's stretching the network, that network cannot be stretched anymore with HCX because it will literally break your network, you get loops and your network will crash. So it needs to be a non-stretched, non-federated, non-global network whatsoever that you can only then you with HCX. What HCX can do, didn't put it on, what HCX can do is if you have, for instance, 2 cloud environments, I can stretch the network to up to 3 different environments. So I can have my local blue network live in AWS, in Google, and in Oracle. That does work. Now, of course, if the VM on AWS and Oracle want to talk to each other, it will go to on-premise and to the other side. So latency-wise, I don't know what it will do to it. But that can work. And you can also, with HCX, do in parallel. So you can make one stretch to here, and from there you can make one other stretch.
Can you use HCX to migrate from Oracle to VMware on AWS?
It's not migrate, it's move, even though VMware keeps calling it migrate. You can move from HCX to HCX. I don't care where the VMware environment lives. No, you definitely don't need an on-premise. If you have VMware on AVS and you have VMware on the Oracle Cloud, and of course you want to move away from AVS and you want to move to the Oracle Cloud, or the other way around, you can fully use HCX for that. So it's perfectly fine to use HCX from cloud to cloud, from cloud to on-premise, whatever. When you do from cloud to cloud, you don't have to license the other one anymore because it's already licensed anyway. But yeah, so it doesn't matter where the VMware environment sits at all. I do frequently, all my demos, I use a demo between my home environment and the cloud. Nowadays I just have 2 environments in the cloud and I just HCX between those 2 environments. So that's perfectly fine as well. It doesn't matter where it sits at all. As long as you can deploy an HCX appliance. So that's the only way. Sometimes I have customers that use a hosting company and they are running the VMware platform today for them on-premise. They can't deploy this HCX appliance. So you have to get permission, whoever's running your VMware platform, that you're able to deploy the HCX appliance. If you can't deploy in your own environment the HCX appliances, the buck stops there. So you have to have control over that environment that you can deploy HCX. Else you can't do it. Yeah?
Any good reason why the migration performance is so constricted?
Good question. We've asked this a few times to VMware. They're looking into it. Because the VM has a certain size, so it's not like the appliances. You can't say, give it 8 more CPUs or whatever. I've tried. I've made the VM larger, didn't improve performance. VMware has I don't know where it is, but it is limited within the appliance on doing things with the encryption, the compression. I have no clue. These are the limits. I don't know if they will go up, but this is right now. It doesn't. Because of course you can go to the appliance, make the VM larger and that kind of stuff to see if you get better performance out of it. We weren't able to do it, and we tried, trust me. So these are the limits. Yeah, and I don't know why. You have to ask VMware's engineering team, I think. Any other questions? Because I think we're on time now. No? If not, I'm at the, one more?
One of the slides you have 3 segments on the second slide.
Yeah.
3 logical segments. When you migrate a logical segment to the cloud, there is a suite of firewall rules that manage the networks between these logical segments.
Yeah. It depends what your firewall technology is on the left side and what your firewall technology is on the right side. If you're on NSX over there and you're using NSX firewalling and you're using tags, for instance, to do it, HCX can move the tags with the VM. There's an option during the migration that you can make sure that the tags get applied as well. You still need to implement the rules, so you need to do synchronization of NSX, for instance. There's a product called REST NSX that can do rule synchronization between NSX environments and that kind of stuff, third-party product. But most customers don't use. Most customers have to re-implement a firewall on the right side and somehow synchronize it up and whatever. Most of my customers actually don't even implement their firewall on the VMware stack because they only care about north-south traffic. So they implement a FortiGate or whatever, and they deploy that natively in our cloud. And they just make sure that all the NSX traffic first goes to that firewall and then goes to wherever. And because then they can use the same product, whatever firewall they have on-premise, and therefore use the same technology, synchronize, have the same policies and that kind of stuff. So that's how most customers I see in the field solve that problem. But it is something they have to do manually.
But when you added this extra NIC to the VM, to the application VM to talk to the database VM, you override everything.
No. So if I send that to that IP address, depending on, I can still control the routing rules on the tier 0 VLAN, and I can still say that all that traffic should go to my firewall and it first flows to the firewall. Yeah. So I can override it, but I can change the route towards that IP address. Yeah. So I can still redirect that to a firewall if I want to. Yeah. That's it for my time. Thank you very much. If you need more questions, I'm floating around. I'm at the party tonight. I'm here tomorrow, so feel free to come to me. Thank you very much for attending.